Hello, everyone, and welcome back. Today, we're tackling one of the most talked about concepts in distributed systems, the CAP Theorem. Now, there is a lot of content about CAP Theorem out there, but honestly, most of it makes the topic way more daunting and theoretical than it needs to be. Worse, almost none of it explains why CAP Theorem actually matters in the context of system design interviews and how you should use it in your design discussions. Well, today I'm going to cut through all the complexity and show you exactly what CAP theorem is, why it matters for interviews, and most importantly, how to apply it when you're designing systems. By the end of this video, you will know exactly how to use CAP theorem to guide your design decisions and, most importantly, impress your interviewers. Awesome, let's dive in. Let's start with the basics. CAP theorem states that in a distributed system, you can only guarantee 2 out of 3 properties simultaneously. Those 3 properties are consistency, availability, and partition tolerance. Let me break down each one. Consistency means that all node or all users see the same data at the same time. When you write data to the system, everyone reading that data immediately sees the updated value. There is no stale or updated data. Every read returns the most recent write. Let me give you a concrete example. Imagine you have a distributed database with 3 servers, server A, server B, and server C. You update your profile picture on a social media app. That write goes to server A. Now, if your friend immediately tries to view your profile and the request goes to server C, the question here to ask is, do they see your new profile picture or your old one? Well, without consistency, your friend might see your old profile picture for a few seconds or minutes until server B catch up with the update from server A. Different users hitting different servers see different versions of your data. With strong consistency, in the other hand, they see the new picture immediately. All 3 servers, A, B, and C, have the exact same data at the exact same moment. The system ensures that before confirming you're right, all servers are updated. Everyone sees the same thing. Think of consistency like a shared Google Doc, where everyone is looking at the exact same version. When one person makes an edit, everyone viewing the document sees the change immediately. That's consistency. Everyone has the identical view of the data at any given moment. Now, second property is availability. And we've already discussed this in the previous video, but I'm going to give you kind of a high-level overview about availability again. And basically, availability means that every request gets a response, whether successful or not. The system remains operational and responsive. Even if some components have failed, the user can always interact with the system and get an answer. Though the answer might not always contain the most recent data. Contrast this with low availability. If the system prioritizes other properties over availability, when there is a problem, you might get a complete error. For example, service unavailable, try again later. The system refuses to respond because it can't guarantee the quality of the response. Now, the last property, partition tolerance. Partition tolerance means the system continues to work despite network failures between nodes. In a distributed system with multiple servers, network issues can cause some servers to be unable to communicate with each other. This is called a network partition. Partition tolerance means your system keeps functioning even when these communication failures occur. Now, here is the key insight of CAP theorem. In a distributed system, you cannot achieve all 3 properties at the same time. You can have consistency and partition tolerance, or availability and partition tolerance, but not all 3 simultaneously. You have to choose 2. But wait. What about consistency and availability? Well, in practice, partition tolerance isn't really a choice. Network failures are unavoidable in distributed system. Networks are unreliable. Cables get cut, routers fails, data center loss connectivity. You can't just decide to not have network partitions. They will happen. So partition tolerance is a must. You have to design for it. This means the real choice you're making is between consistency and availability. When a network partition happens, do you prioritize keeping data consistent across all nodes, or do you prioritize keeping the system available and responsive to users? That's the core trade-off of CAP theorem. Awesome. So now you understand what CAP theorem is, but why should you care about it in a system design interview? This is the part that most explanations miss entirely. Here's why it matters. In system design interviews, the very first thing you want to do is align on requirement with your interviewer. This typically breaks down into two categories, functional requirement and non-functional requirement. We'll break down all this in the delivery framework video later in the course, but just to give you a high-level overview about the requirement. Now, functional requirements are what the system does, the features, the capabilities. For example, users can post messages, user can search for product, user can upload videos. In the other hand, non-functional requirements are the qualities of the system, how it should behave. This includes things like availability, performance, security, scalability, reliability, durability, and so on. Now, when you're discussing non-functional requirements, one of the first things you should do is think about CAP theorem. You should explicitly ask yourself and discuss with your interviewer, does this part of the system need to prioritize consistency or availability? Why is this so important? Because this shows will have a significant influence later on the deep dive of your design. It affects what databases you choose, how you structure your architecture, what trade-offs you make, and how you handle failures. Let me be concrete here. If you're designing a system that prioritizes consistency, you might choose a traditional relational database with strong ACID guarantees. No worries, we will explore relational database later in the course. Maybe you can implement synchronous replication and design your system to reject requests during network partitions to avoid serving stale data. If you're designing a system that prioritizes availability, in the other hand, you might choose a NoSQL databases with eventual consistency. Implement asynchronous replication and design your system to always accept requests even if it means temporarily serving slightly updated data. These are fundamentally different architectural approaches and they stem directly from your choice in the CAP theorem. Making this choice explicit early in the interview shows that you understand distributed system, you're thinking about trade-offs, and you're making intentional design decisions rather than just throwing components randomly. So here's what I recommend. After you've gathered functional requirements with your interviewer and you're moving into non-functional requirements, explicitly state something like, now thinking about the non-functional requirement, I believe the system should prioritize either consistency or availability because, and then explain your reasoning. This immediately demonstrates sophisticated understanding to your interviewer. Now let's look at concrete examples of systems that should prioritize consistency over availability. Banking and financial systems. This is the classic example. Imagine you have $100 in your bank account. You withdraw $80 at an ATM. Your account balance should immediately reflect $20 remaining across the entire system. You shouldn't be able to simultaneously withdraw another $80 at different ATM because that ATM hasn't yet learned about your first withdrawal. In banking, consistency is absolutely critical. You cannot have different parts of the system showing different account balance. It's better for the ATM to temporarily become unavailable to reject your transaction than to give you money you don't actually have. This could lead to fraud, financial losses, and legal issues. Banks choose consistency over availability. During network partition, they would rather fail transaction than risk inconsistent financial data. Second, booking systems. Hotel reservations, airline seats, appointment scheduling, these all require consistency. You can't double book a hotel room or sell the same airline seat to two people. The system needs to ensure that when someone books a resource, that resource is immediately marked as unavailable everywhere in the system. Airlines would rather have their booking system become temporarily unavailable than accidentally book the same seat twice, which would cause massive operational problems. Awesome. Now let's look at the other side, systems that should prioritize availability over consistency. Social media feeds. Think about your Facebook newsfeed or Twitter timeline. Is it critical that every user sees exactly the same post in exactly the same order at exactly the same moment? Not really. If one user sees a post a few seconds before another user, or if different users see slightly different version of the feed, it's not a big deal. Social media platforms prioritize availability. They want their site to always be responsive and functional even during network issues. If the trade-off is that some users might temporarily see slightly outdated data or different users might see slightly different content, that's acceptable. It's better than the entire site going down. Another example is content delivery and streaming. For example, Netflix, YouTube, Spotify, these services prioritize availability. They want to ensure users can always browse and stream content, even if it means different users might see slightly different catalog metadata or recommendations for a brief period. It's much worse for networks to be completely unavailable than for some users to temporarily seize outdated information about a show's rating or number of episodes. The core functionality, streaming video, need to always work. Here's where things get really interesting and where you can demonstrate advanced understanding in interviews. Real-world systems don't uniformly prioritize consistency or availability across the entire system. Different parts of the system have different requirements. This is called having a hybrid requirement. Some components prioritize consistency while others prioritize availability. Let's look at that e-commerce example more closely. An e-commerce platform like Amazon has different requirements for different parts of the system. The product browsing and search component prioritize availability. Users should always be able to search for product and browse listing even if some product information is slightly stale. If there is a network partition, serve cache data and keep the site functional. The shopping cart is in the middle. It's kind of flexible. If you add items to your cart and there's a network issue, the system can accept your addition and sync it later. Slight delays or inconsistency in cart content across devices aren't critical, to be honest. But the checkout and payment component absolutely prioritizes consistency. When you're charging someone's credit card and deducting inventory, you need strong consistency. You cannot have duplicate charges or oversold items. During network partitions, it's better to fill the transaction than to risk financial inconsistency. This hybrid approach is how most real world systems are actually built. You don't make a single cap choice for the entire system, but you make different choices for different components based on their specific requirements. So, how do you actually use this in a system design interview? Let me give you a concrete framework. Step 1. After gathering functional requirements with the interviewer, explicitly discuss CAP Theorem. Say something like, before we dive into the architecture, I want to think about the CAP Theorem and our consistency versus availability trade-offs. Step 2. Identify which part of the system have which requirement. Don't just say, this system needs consistency or this system needs availability for everything. Instead, what you can say, the browsing experience should prioritize availability because users always need to interact with the catalog, but the checkout process should prioritize consistency because financial accuracy is critical. Awesome. Now for the step 3, with the CAP theorem will guide your technology choices. If you say the component needs consistency, choose databases and architecture that support strong consistency, like relational databases with ACID transaction, synchronous replication, and coordination services. If you said a component needs availability, choose technologies that support eventual consistency, like DynamoDB, Cassandra, or eventually consistent caching layers. Step 4. When discussing trade-offs later in the interview, refer back to your CAP decisions. For example, we choose PostgreSQL for the inventory system because we decided that consistency was critical there, even though it means we have a single point of failure that we will need to address with replication. This demonstrates that you're not just randomly picking technologies, you're making intentional, reasoned choices based on requirement. Okay, that's it for the CAP theorem. Hope this video was informative for you. I will see you in the next one. Bye bye.